Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 5 questions that I've seen in the comments section of my videos over the course of the past week or two. In all honesty, I think we can all benefit by taking a closer look at these questions, since as you'll see in just a few minutes, some of them are pretty challenging. That said, I ask that you treat this video like a mini ASVAB math practice test. That is to say, you should pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB, so as you work your way through these practice questions, try not to use those resources. So all that being said, let's go ahead and get started with today's video. All right, so this first question says, evaluate the expression x plus 4z minus 5 minus 3x when x equals 2 and z equals 2x. All right, so if you watched my video called Evaluating Algebraic Expressions, you'd realize that the first thing I recommend you do is to copy down your expression. And in this case, our expression is x plus 4z minus 5 minus 3x. And in addition, we were told that x is equal to 2 and z is equal to 2x. All right, normally you would plug in 2 for x, and then usually you would have a whole value for z that you can then plug in as well. But in this case, we were told that z is 2x. So the first thing I want to do in this case is try to write z as a whole value. And how am I going to do that? Well, z is 2x, and we know x is 2. So we can take this 2 and plug it in for x. So this becomes 2 times 2, and we should know that 2 times 2 is 4. So as a whole value, z is 4. So now we can plug in 2 for x and 4 for z, and then simplify this expression accordingly. All right, so let's go ahead and do that. This becomes 2 plus 4, again, z is 4, minus 5 minus 3 times x, x is 2. All right, let's work this out now. Again, according to the order of operations, we do multiplication before addition and subtraction. And in case you have a hard time simplifying an expression like this, it may be helpful to write your order of operations off to the side. Again, I remember my order of operations using the acronym PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, subtraction. This tells you the order in which to simplify an expression like this. That is to say, you do what's in parentheses first, if there is anything in parentheses. Then you do exponents next, if there are any exponents. Then you do multiplication and division as they appear in the expression from left to right. And then finally, you do addition and subtraction as they appear in the expression from left to right. If we quickly look through this expression, you can see that we have addition right here, multiplication here, subtraction here, and multiplication here. Of course, we're going to do multiplication before addition and subtraction. So let's go ahead and take care of that. This becomes 4 times 4 is 16. So this is 2 plus 16 minus 5. And let's take care of this multiplication here as well. 3 times 2 is 6. So this is 5 minus 6. All right, so we took care of all of our multiplication. And as you can see, the only thing we have left is addition and subtraction. Again, you work out addition and subtraction as they appear in the expression from left to right. That is to say, they are equals. So what I'm going to do is I'm just going to simply work out this expression from left to right. So 2 plus 16 is 18. So this becomes 18 minus 5 minus 6. 18 minus 5 is going to be 13. So this becomes 13 minus 6. Well, 12 minus 6 would be 6. 13 minus 6 is 7. All right, so the answer to this one is 7. Again, normally you'll have whole values for x and y or z. But that said, if you're ever given something like this, just bear in mind you probably can plug the other whole value into the other one and then simplify accordingly. All right, so that's a pretty good question there. Let's go ahead and move on. All right, so this second one says solve the expression for x. We have negative x squared minus 5x squared plus 30 equals 0. So not surprisingly, let's get started by copying down the expression. We have negative x squared minus 5x squared plus 30 equals 0. So at first glance, you might be saying to yourself, well, can I factor this? And the answer to that is, if you're good at factoring, you probably could. That said, this problem is designed to look like a problem that you can factor, but it's just one you're going to solve algebraically. So let's go ahead and work on solving this one algebraically. First things first, right away, I see a pair of like terms, notably negative x squared and negative 5x squared. Again, like terms have the same letter variable raised to the same power. In this case, we have the letter variable x raised to the second power, and here we have the letter variable x raised to the second power. So since those are like terms, we can go ahead and combine them. Negative x squared minus 5x squared is negative 6x squared, and then this is plus 30 equals 0. Again, our goal in this case is not to factor this expression, but to solve for x. So in other words, we want to get x by itself. So I'm going to start rearranging this expression such that I eventually get x by itself. So let's go ahead and start by subtracting 30 from both sides. This crosses out here, leaving you with negative 6x squared equals negative 30. Again, our goal is to solve for x. So as my next step, I'm going to divide both sides by negative 6. This crosses out here, leaving you with just x squared over there. Negative 30 divided by negative 6. A negative divided by a negative is going to be a positive. In fact, negative 30 divided by negative 6 is going to be positive 5. All right. And to get rid of this square, we're actually going to take the square root of both sides. This will cross out here, leaving you with x. And when you take the square root of both sides, your answer actually becomes plus or minus the square root of 5. So our answer to this one is x equals plus or minus the square root of 5. All right, so as you work through the mathematics knowledge subtest of the ASVAB, you have to be mindful that sometimes some questions are going to look as if you can factor them, but in reality, you're just going to solve them for x algebraically. And this was a good example of that, and that's why I included it in this video. All right, let's go ahead and move on to the next one. All right, so number 3 says it takes 3 glasses to make a quart. If a glass is a quarter filled, what part of a quart is in the glass? All right, so at first glance, you might be saying to yourself, well, there are 4 cups in a quart, and this is a conversion problem. While there are 4 cups in a quart, you have to pay attention to the wording of a question. This says glasses, and as it happens, there's a lot of different types of glasses. There's shot glass, beer glass, coffee mug, and so on and so forth. So if this was a conversion problem, this would say cups. But since this says glasses, that's a clue that we're going to be using a proportion to figure this one out. And if you watched my video on proportions, you would know that they are nothing more than 2 fractions that are equal to each other. And as it happens, you fill in proportions like this. You take the information that's given and you put that on the left-hand side of the equal sign. Then you take the information you're trying to figure out and you put that on the right-hand side of the equal sign. Well, what's given in this problem? In this problem, it tells us it takes 3 glasses to make a quart. So I'm going to write 3 glasses for every 1 quart. All right. If a glass is a quarter filled, what part of a quart is in the glass? Well, that what part of a quart is unknown. And in math, we represent unknowns with letter variables. So I'm going to call that x of a quart. And The way you fill in the right-hand side of this proportion is like this. Since we have quarts in the denominator on this left-hand side, we're going to keep quarts in the denominator over here. And since we have glasses in the numerator, we're going to keep glasses in the numerator over here. If a glass is a quarter filled, so that means we have 1/4 of a glass. And we want to know what part of a quart that is. So that's going to be x of a quart. All right, now that we've set up our proportion correctly, the next step is to proceed by doing cross multiplication. I'm going to do 3 times x first, which is 3x. And then I'm going to do 1 times 1/4. Well, what is 1 times 1/4? Anything times 1 is itself. So 1 times 1/4 is just going to be 1/4. And again, we're solving for x. So our next step is to divide both sides by 3. This crosses out here, leaving you with x. All right, so the challenging part of this problem is the fact that we're left with 1/4 over 3. And I'm actually going to work that off to the side here. Again, we have 1/4 over 3. First, you have to realize that this fraction bar is also division. So you can read this as 1/4 over 3, or you could read it as 1/4 divided by 3. All right, so we're going to treat this as division. That said, to make this a little bit easier, we can actually write 3 as a fraction by placing it over 1. So now this says 1/4 divided by 3 over 1. And in light of that, we can follow this algorithm to divide two fractions. Again, when you divide two fractions, you follow the algorithm keep, change, flip. That is to say, you keep this top fraction the same, so this is 1 over 4. You change this from division to multiplication, and then you flip this bottom fraction. So instead of being 3 over 1, it's going to be 1 over 3. All right, and multiplying fractions is actually very easy. Just multiply straight across. That is to say, you would do 1 times 1 over 4 times 3. 1 times 1 is 1. 4 times 3 is 12. All right, so the answer to this one is 1 over 12. In other words, if you have a quarter of a glass, that means there's 1/12 of a quart in it, given this ratio over here. All right, so that's that one. Good test of your ability to work with fractions as well as proportions there. And let's go ahead and move on now. So number 4 says a television show is 60 minutes long. During the show, there are 4 1 1/4 minute commercials. Approximately what percentage of the show is a commercial? So before we can actually answer this one, that is, before we can say what percentage of the show is a commercial, we have to figure out the total length of the commercials during this show. And that's actually pretty easy to do. Again, we know each of the 4 commercials is 1 1/4 minutes long. So let's just go ahead and add those up. All right, now you should be able to do this math mentally, because let's do this together. We have 1 plus 1 plus 1 plus 1, which is 4. And then let's add these quarters together. 1/4 plus 1/4 is 1/2, plus another quarter is 3/4, plus another quarter is 4 over 4. 4 over 4 would be 1. So this is 4 plus 1, or 5. So in total, these 4 commercials run for 5 minutes. Now we can work on answering this question. What percent is 5 minutes out of 60 minutes? And that looks like this, 5 over 60. And we can convert this to a decimal and then to a percent by treating this like long division. That is, by reading this as 5 divided by 60. Well, to be honest with you, I don't want to get stuck doing that math. So what I'm going to do is try to simplify this as much as possible. And you should realize that both 5 and 60 have a common factor of 5. 5 divided by 5 is 1. 60 divided by 5 is 12. All right, so now I'm going to go ahead and proceed with my long division. Again, I'm going to read this as 1 divided by 12. And there's a reason I'm putting a very long division bar there. And we start by asking ourselves, how many times does 12 go into 1? It doesn't. So I'm going to put a 0 here to indicate that 12 did not go into 1. That said, I still have to work this problem out. So what we're going to do next is we're going to add a decimal place and a couple of 0 placeholders. And I'm going to add, let's add 6 of them. I may not use all 6 before I get my answer, but I put 6 just in case I need them all. All right, once I add my decimal down here, I actually have to drag it up into my answer, and I can actually disregard the decimal down here now. Okay, so I'm going to move on and ask myself, how many times does 12 go into 10 without going over? It doesn't. Again, 10's too small. Now the question is, how many times does 12 go into 100 without going over? Well, that's going to be 8 times, given that 12 times 8 is 96. 100 minus 96 is 4. And now we get to drop down one of our 0 placeholders. And the question becomes, how many times does 12 go into 40 without going over? Again, that's going to be 3 times, given that 12 times 3 is 36. 40 minus 36 is 4. Again, drop down one of our zeros. How many times does 12 go into 40 without going over? Again, that's going to be 3. 12 times 3 is 36. And we should see a pattern here, notably that this is going to be 0.08333 repeated. So let's just finish this off. This is 4, drop down a 0, and we would see that this is 3. So again, the question asked us to approximate our answer. So I'm going to take 0.08333 and I'm going to round it. More specifically, I'm going to round it right here. So I'm going to look to the right of this 3 that's in the box. And if the number to the right is 5 or greater, I would round up. If it's 4 or below, I keep this number the same. As we can see, the number to the right is a 3. So I'm just going to keep this as 0.083. All right, so 1 over 12 is approximately 0.083. Now we got to convert this to be a percent. Well, to convert a decimal to a percent, you simply multiply that decimal by 100. And whenever you multiply a decimal by a power of 10, such as 10, 100, 1000, and so on, all you do is take that decimal and shift it to the right according to how many zeros there are in the power of 10. Well, in 100, there are 2 zeros, so that's going to prompt me to take this decimal and shift it 2 times to the right. So as we can see, this would be 8.3%, approximately. So approximately 8.3% of this show is filled with commercials. And as you saw, this question tested our ability to add mixed numbers as well as to perform long division. All right, so that's a very good question. All right, so number 5 says the weight of 2 automobiles can be expressed as a ratio of 2 to 5. If the lighter automobile weighs 1,500 pounds, then how much does the heavier automobile weigh? All right, so if you watched my video yesterday on ratios, rates, and proportions, you'd realize that we can actually use a proportion to quickly solve this one. And again, a proportion is nothing more than 2 fractions that are equal to each other. And as it happens, we set up this proportion by filling in the information that's given on the left-hand side of the equal sign, and then we fill in the information we're trying to figure out on the right-hand side of the equal sign. Well, what's given in this problem? The weight of the 2 automobiles have a ratio of 2 to 5. So that ratio of 2 to 5 is given, so I'll go ahead and fill that in right here. And just so it's clear, this 2 refers to the weight of the lighter automobile, whereas this 5 refers to the weight of the heavier automobile. All right, so let's look through our problem. If the lighter automobile weighs 1,500 pounds, then how much does the heavier automobile weigh? Well, that's an unknown. So I'm going to let x refer to the weight of the heavier automobile. All right, so let's fill this in accordingly. Again, we're going to put 1,500 in our numerator since that's the weight of the lighter automobile over x. And we can solve this one now using cross multiplication. I'm going to do 2 times x equals 5 times 1,500. And again, we're going to be solving for x, so let's go ahead and divide both sides by 2. And this leaves us with x equals 5 times 1,500 divided by 2. If you're good at mental math, you could solve this one pretty quickly. But that said, I'm going to work out each and every step. First, I'm going to do 1,500 times 5. 0 times 5 is 0. 0 times 5 is 0. 5 times 5 is 25, so drop down a 5 and carry a 2. 5 times 1 is 5, 6, 7. So this becomes 7,500 over 2. And again, if you're good at mental math, you wouldn't have to work this off to the side. You would know the answer. But that said, if you're not good at mental math, you could read this as 7,500 divided by 2. And we start by asking ourselves, how many times does 2 go into 7 without going over? Well, 2 times 4 is 8, which is too big, whereas 2 times 3 is 6. So 2 times 3 is 6. 7 minus 6 is 1, and of course we drop down this 5. Now the question is, how many times does 2 go into 15 without going over? 2 times 8 would be 16, which is too big. 2 times 7 will be 14, so this is going to be 7. 2 times 7 is 14. 15 minus 14 is 1. Drop down this 0. Now let's think about this right here. We do know that 2 times 5 would be 10. But can't we solve this one by dropping down this other 0 and making this 100? Because we know 2 times 50 would be 100, so we would have no remainder. All right, so just like that, we perform the long division. And in light of that, we know the weight of the heavier car is 3750. And of course, that's pounds. All right, so that's that one. All right, so that's it for this video. As I mentioned, these were some questions that I saw in the comment section of my videos, and I thought it'd be helpful to share them with everyone who watches my channel. If you have any more questions that you come across that you find difficult, feel free to either email them to me or write them in the comment section. And if I get enough of them, I'll make another video like this one. As always, I hope you found this video helpful. And as usual, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider subscribing to it. But on that note, I'm going to go ahead and catch you loose. こんにちは。